Okay, so I am going to do a couple of the labs just because we're probably not going to have too much time to do them in class, but try to do them on your own, again, like we would in class, just because you're going to learn the most that way. So on, let's see, 12C, go ahead and look at that and maybe pause the computer right now, try it on your own, and then unpause and we'll go over it together. Okay, so let's look at this. So again, these are kind of the methods we did in class. So if I have this, say, right triangle that's shaded, I could, say, double it and then take half of the area that way. So it would be what? 1, 2, 3, 4, 5, 6. What is it? 6 by 4? Okay. So then there would be 24 squares in here total if I drew all the squares. So then I would know that I'd have half of 24 and get 12, say, I don't know, square centimeters or something like that. Okay, so that's one option. The other option, which actually looks similar because of the fact that it's a right triangle, is fill in the rectangle. So the first time I was kind of doubling and putting it over here. Here I'm just drawing in the rectangle. So again, this triangle equals this triangle, so I get half the area. And then the other one, I should be able to cut it. So remember, I should be able to maybe cut this top off at some point and then move it into that space right there. And so instead of being 6 by 4, this used to be 4 and 6. Now this is what, 6 by 2 for this new rectangle that I just made, which is 12, square centimeters or something like that. All right, and we can do those same ideas on the next triangle. It's just not quite as easy as a right triangle. So the first one kind of comes, over there. And what's the base on that one? 1, 2, 3, 4. And the height is at 1, 2, 3, 4, 5, 6. So the height is always at a right angle, and that's 6. So again, this triangle is going to have the exact same area as the first one did. So one thing we could do is double it. So if this is my shaded, right, I could double it and kind of fill it in right there. Right, and again, I should, and again, I'm not very good at drawing, but I should get a parallelogram. So then again, I have half that parallelogram. So I get half of 24, which is 12 square centimeters. Okay, so that's one way. The other way is going to look a little different this time. The other way, I guess I could move that, is to fill in the rectangle. So I could draw in my rectangle and notice that these two are going to end up matching, these two are going to end up matching. So the white space and the shaded space are equal. So I can take 4 times 6 and get 24 for the big rectangle, but know that I only have half of it and get my 12 square, I could do square centimeters that way. So that's kind of filling in the rectangle and noticing that only half is shaded. And then the other one is cutting off the top. Okay, so if I kind of, let's see, this is 6 tall. So if I cut this right here at the 3 mark, at the halfway mark, then I should be able to move this, right, to create a parallelogram. So should be able to move it into that space right there. So let's see what's going to happen here. So then now, let's see, let me change markers here. So then now my height is 3. So I'll go right there. So my height is now 3. So again, I have 4 by 3. And so 4 times 3 is 12 for my new kind of shorter, right? No longer a triangle, but a parallelogram, but the height is got in half. So that's kind of how we would have done. We did those in class, but that's kind of how lab 12C would look. All right, I want you to try 12D. And our 12D, again, try it on your own. This is actually more challenging than you might think. So try to draw in the base and height for all of those. So remember, when you have a triangle, your base and your height always have to be at a right angle. So if you have like something like this, here's your base, and from your highest point to your lowest point straight down at a right angle, that is what your height is. So pause the video, try to mark the base and height for triangles 1, 2, and 3 there. And they're the exact same triangle, but any side can be a base and any side can be a height. So go ahead and try to do that. All right, so I am back. And so let's look at the 3 triangles that we have here. Again, they're the same, but we'll rotate them. So usually what people want to do is they want the base and height to be inside their triangle. So if this is my base, from the tallest point to this lowest point, straight up and down, this would be my height. And so having the base and height, having that height inside the triangle is pretty common. But any side can be the base, and any side can be the height. All right? Or, no, sorry, that didn't sound right. Any of the 3 sides can be the base, and then the height would be determined by that. So the height does not have to be inside the triangle. So if I want this to be my base, I need from the lowest point, which is on this level, this is my lowest point on my shape, I need it to go to the highest point on my shape, which is this point right there, at a right angle. And so notice what is going to happen is your height is going to be outside your triangle. And sometimes with kids, this messes them up when they try to find, say, perimeter or something like that, because as a teacher, maybe you have this as, 8 foot and 7 foot, and then maybe 10 feet, something like that. And then maybe your height over here is at 5 feet. And so sometimes students just, they add all those numbers to the perimeter. This is not really part of the problem. It's that dashed line is just kind of like someone whispering to you, like, hey, by the way, height is 5 feet. When we do this on dot paper, the nice thing is you can figure it out yourself on dot paper. You might need Pythagorean theorem to figure out this side. You might have to do a squared plus b squared equals c squared. But this height should be countable if we're on dot paper. All right, so that's with that one, the base. We've done that as the base. So now this last side can be the base. All right, so if this is my base, then this is my lowest point, right? And what, up here, and again, I might rotate this a little bit. That might help my brain. I don't know how good that is for you guys. But then this point is my highest point, and it has to touch my base at a right angle. So again, this would be my height, okay? So the base and the height always have to hit at a right angle, whether it's inside, which is only would happen if this is your base, then they would hit inside. Otherwise, you got to kind of extend out your base with a dashed line and figure out where that tallest point touches at a right angle. All right, so we will do some problems on dot paper with that, but just make sure you know how to find the base and height of a triangle. And I am going to turn this off, and we'll do another video with a couple other labs here.